Hello everyone. In previous lectures, we have studied complex frequency domain analysis for continuous time signals and studied the S-domain description for LTI systems. In this lecture, we will discuss S-domain analysis for LTI system response. First, we will discuss relation between H of S and YZS of S. In time domain, we can get the relationship between output signal and input signal. In S domain, we can get the relationship between the input signal and output signal. In time domain, we can use different equations to get the system responses. In S domain, we can use unilateral Laplace transform to get the equation in S domain and solve the equation to get the response Y of S in S domain. Then by the inversion of unilateral Laplace transform to get the response in time domain. For example, according to this differential equation and the input signal initial state to find the system response, it includes these steps. First, by unilateral Laplace transform to find the algebraic equation in S domain. Then, solving the algebraic equation, obtain YZIS and YZSS. Finally, by inversion of unilateral Laplace transform to obtain YZIT and YZST. According to differentiation property of unilateral Laplace transform, we can get this equation in S domain. Reorganize it, we can get this equation. This fraction corresponding to YZIS, because when input signal is 0, this fraction is 0. So this fraction corresponding to the YZIS. Similarly, we can get this fraction corresponding to YZSS. According to the initial state, we can get YZIS. By the partial fraction expansion, we can get the 0 input response for this system. According to this equation and the input signal, we can get YZS of S. By partial fraction expansion, we can get this equation. By inversion of unilateral Laplace transform, we can get the 0 state response for this system. The total response equals 0 input response plus 0 state response. This is for you to exercise it. We have given answers. It's another exercise. We have also given the answers. You can try it. It's another one. We need to determine the zeros input response and zero state response, transfer function, impulse response, the structure diagram for this system. First, by unilateral Laplace transform, we can get the equation in S domain. According to the initial state, we can get the YZIS. By partial fraction expansion, we can get this expression. By inversion of unilateral Laplace transform, we can get the zero input response for this system. This is a YZS of S. This item corresponding to the unilateral Laplace transform for input signal. By partial fraction expansion and the inversion of unilateral Laplace transform, we can get the zero state response for this system. Finally, we can get the total response for this system. It equals zero input response plus zero state response. Now we are determining the transfer function and the impulse response. According to YZS of S, we can get the system transfer function. By partial fraction expansion, we can get the impulse response for this system. The causal LTI system is stable because all the poles are located in the left half of S-plane. Finally, we will discuss the structure diagram for this system. According to the system transfer function, we can get this equation. According to this H of S, we can get the structure diagram for this system. These two correspond to these two. 3, 7, 10. The fourth pass corresponding to the numerator. Feedback pass corresponding to the denominators. In this lecture, we have discussed the S-domain analysis for LTI system. That's all for today. See you later.